Hi guys, so in this video lecture we'll be talking about hyperconjugation in free radical. So let me start off with the topic. So before that, just for the information sake, that if we have to find the number of alpha hydrogens in benzene rings, then uh, that can be answered by that number of alpha hydrogen in benzene are is uh, hydrogens attached to carbon, which in turn is substituted on the benzene ring, right? Okay, so let's say this is our benzene ring. So number of alpha hydrogen for this benzene ring is 3. Why? Because this is the alpha carbon and these 3 are the number of alpha hydrogen attached to this alpha carbon. Okay, so now let's jump on to our today's topic, hyperconjugation in free radical. Okay, so let me start off with giving you some example that this is a free radical. So what would be the number of alpha hydrogens attached to the alpha carbon? So those are 3 in number. Okay, so as you can imagine, we can draw some of the resonating structures when we actually remove the H plus cation from this carbon atom, so resulting in negative charge, or here as we saw in hyperconjugation in case of a cation, but here we can actually have is we'll be removing hydrogen with free radical, or one electron would be shared among carbon atom and hydrogen atom during the homolytic fission of the bond. So this can be the resonating structure when actually these two electrons come into creating a double bond between the carbon atoms. Okay, so I hope you understand that the stability of compound or a free radical is also directly proportional to the number of alpha hydrogens it has. Okay, so let us compare the stability between this compound and this compound. As this compound is having 9 alpha hydrogen and this is only having 3, hence the stability is this compound is more stable than the first compound. Now let us have this example. So which is actually more stable in this case? Obviously this is more stable. Why? Because it is having 9 alpha hydrogen, due to which negative charge will come onto this carbon and this carbon, so it would have high amount of negative charge within the compound, so it would be highly unstable. Okay, so as a result this would be relatively more stable than the second compound. Okay, so let us do some exercise on calculating number of alpha hydrogen in the following organic compounds. Okay, we have something like, start off with simple toluene. So how many alpha hydrogens are there? 3. Let us start with second example. Let us take benzene substituted with a cyclohexene ring. So how many alpha hydrogens are there? This is the alpha carbon, this is the alpha carbon, it is at 2 hydrogen, this carbon atom also has 2 hydrogen, total 4. Okay, let us look at this example. we have this. So how many alpha hydrogens are there? This is the alpha carbon, this is the alpha carbon, and this is the alpha carbon. Here we have 2 alpha hydrogen, here we have 2 alpha hydrogen, here we have only 1 alpha hydrogen. So 2 plus 2 plus 1, 5 alpha hydrogen are there in this compound. So let us now compare stability of the following organic compounds. Compare stability. So as you may know that the stability of a compound is directly proportional to the number of alpha hydrogens in case it is a in case in all the cases, I mean whether it is a cation or anion or a free radical, right? Why? Because we will have more number of resulting structures which are derived by removing hydrogen or H plus cation from the corresponding carbon atom. Okay, so let us compare the stability order of the following carbon compounds. This so how many alpha hydrogen does this compound contain? 2, 2, 4, 4 plus 3, 7, 7 plus 3, 10. So 10 alpha hydrogen. How many alpha hydrogens here? 2 plus 1 plus 3. How many? 6. How many here? So 2 plus 1, 3 alpha hydrogen. So the stability order is this. Let us have example like just a second. Yeah, this one and this one. So how many alpha hydrogen does this compound contains? 2 plus 1, 3 alpha hydrogen. How many for this one? 2 plus 2 plus 2 plus 2, 8 alpha hydrogen. How many for this compound? 2 plus 2 plus 1, 5 alpha hydrogen. So the order would be 2 is greater than 3 is greater than 1. This is the stability order. Okay. Okay, so let us look at third example. So here we have this compound and you have to compare it with this one. Okay, so how many alpha hydrogens are there in this compound? 3 plus 3, 6, 6 plus 4, 10 alpha. And how many for this compound? So 3 plus 1, 4 alpha. So what would the stability order? This would be the stability order. What about this compound? So this has 3 alpha, 3 plus 4, 7 alpha. This has 2 plus 2, 4, 4 plus 2, 6 alpha. This has 2, 2 plus 1, 3 alpha. So obviously 1 is 2, 3. Let us do for this compound. First one, this is the second one, and this is the third one. Okay, so for this one, number of alpha hydrogen is 3 plus 2, 5 alpha. For this one, number of alpha hydrogen, I think I didn't draw a double bond here. Okay, so for this compound we have 3 plus 3 plus 3 plus 3 plus 1, which is 7 alpha. For this we have only I think 7 alpha. So the order of stability is 2, 1, 3. Okay, so now let's look at another example. Here we have this compound. So number of alpha hydrogen for this compound are 4, number of alpha hydrogen for this compounds are 2. So obviously one is more stable than 2. Let's have for this one, and okay, so how many alpha hydrogen? 12 here, and I think 4 into 2, 8 here. So what would be the order? 1 is more than 2. Okay, so with this we end our lecture. So meet you in the next lecture.